Hello friends, welcome back once again to my channel. So this is the video all about JavaScript fundamentals. So this is kind of an essential topic even for the ABAP world, and all the ABAPers should know JavaScript. So I thought to create a series of videos, and because JavaScript is quite a huge topic and I cannot cover within 5 or 10 minutes. So I just wanted to split it up into multiple videos, and each video will cover certain key concepts. So let's see what are the topics that I'm planning to cover in this particular video. We'll quickly check out the things about JavaScript Engine. I know JavaScript Engine is kind of all abstracted. If you don't know even what is JavaScript Engine, still you can complete your project, but good to know about how JavaScript actually working behind the scene. So that's the reason we'll start with the JavaScript Engine, quickly touch upon the call stack and memory heap, and followed by the single threaded, because JavaScript is a single threaded language. So how we can make then parallel operations, like kind of a call it kind of asynchronous JavaScript. How we can do multiple things together or simultaneously, that we'll see, understand the concepts. We'll quickly check about the JavaScript hoisting, how to hoist our functions and variables in our global execution context. There are certain problems and conflicts happens when there is a collision, or kind of a name collision happens and name conflicts happens because of this hoisting, and how to minimize that problem using IIFE, which is called immediately invoked function expression. Yeah, this is not the only way to remove the conflicts, because there is a concept called ES module, but for this time being we'll just focus on the IIFE to understand what is that and how we can minimize it. There is a good concept about call, apply and bind features, not used much, but call and apply, but there is a very fantastic things we can achieve with this concepts. We'll quickly check that out as well. And finally we'll see the function carrying. So entire things will be theory as well hands-on understanding, so that you can also try out. Nothing installations is needed. I'll be doing entire thing on the browser or something repl it as a online web development IDE. So let's head over to that. So if you have not yet subscribed my channel and coming to my channel for the first time, my request would be to subscribe my channel to support my work, and don't forget to set the bell icon, because it will intimate you the moment I upload a new content. So no more wasting our time. So let's get into the actual discussion. So let's understand like how JavaScript works. So JavaScript is basically a programming language or syntax using which we'll just ask our computer to perform certain tasks. And unfortunately, computer only knows or understand the machine code or machine language, and it's all the binaries. So obviously computer doesn't get any clue like what to do once we just give this file to our computer, unless there is something in between which basically translates or interprets the JavaScript code, and it gives back the computer the form of machine code which computer understands, and then computer only able to perform certain tasks what we wanted. So one of the middleman or in kind of an interpreter what I've seen is basically called a JavaScript engine, and I have given the engine name as V8. V8 is basically most popular JavaScript engine. There are many other JavaScript engines also in the market, but V8 is the most fastest and most popular. It's basically built by Google and written in C++ low level language. So what this JavaScript engine, particularly this V8, actually contains and what it does behind the scene. So before we go into that, let's see what are the different engines are available in the market. If you see this list of ECMAScript engines, there are tons of different JavaScript engines are written. A few to call out is like say V8, which is for the Google Chrome. A few things like SpiderMonkey, it's basically used for this Firefox. Basically like who created the JavaScript, that's Brendan Eich, and he basically from Netscape company, and that's the first company who offered this officially created the browser, and later on this particular things actually being used by Mozilla as a SpiderMonkey. We have Chakra also being used by the Microsoft Edge, and so on. So there's a tons of other JavaScript engines as well, which you can see from this Wikipedia link. So head over to our presentation. So what I wanted to call out is This particular JavaScript engine basically contains certain architectural things which parse the JavaScript code, and it converts into the machine code. Let's see how it does. A very simplified form of the JavaScript engine I have just created. So what it does, when I just give a JavaScript code or a JavaScript engine, it parses the code and it basically creates a tree-like structure by reading out the code line by line, and we call it as an AST, or kind of abstract syntax tree. And we'll see using a simulator how this actually breakup happens. Then that kind of a component, or different piece of the code being passed to the interpreter for the understanding, which generally gets or creates the bytecode, which actually machine doesn't understand. So some in between changes needs to happen, and then only bytecode will be understood by the machine. So earlier days we had only this bytecode, and that's why it was quite slow, because to get these things, optimization was not done that time, much earlier days I'm just talking. And then later on what happened, this compiler was placed into, and which basically does some optimization. So what is the profiler job then? Profiler job is just to understand what are the piece of code that can be optimized. So it's kind of a monitoring component which keeps on checking the codes ahead of time and try to understand how we can that code piece can be optimized. We'll see soon, like at a high level, like how this compiler actually works. And generally this, after doing this all sort of optimization, it basically creates some machine code which is directly understood by the computer. So let's see this particular abstract syntax tree, how it basically gets formed. So if you go to this particular link, you'll see this is the JavaScript code. At the right side, it shows the different tree structure. You can go to the tree tab, and it's quite clear, like it's a variable declarations, it's a function declarations. If you just expand, it will show the variable declarator and so on, the function declaration and the different identifier, etc. And the JSON fashion also, you can see how it actually looks. Similar kind of a component that it builds. So let's create our JavaScript engine to understand how actually this split up happens of the code. So let's say this is our super simplified JavaScript engine, where I'll have my code, very simple, let's name is equal to Somnath, and this code I'm giving it to a function which is my the code parser. And if I just commit out this code, so what will happen, this code will basically split this particular JavaScript code into different components. As I've seen, I know a lot of different advanced and complex things are there in real JavaScript engine, but I just wanted to give like how this actually codes get splitted into, and then it goes to the interpreter, and interpreter understands the line by line of coding. Okay, so finally, as I told, there is a profiler which will keep on monitoring the things, and it will eventually try to optimize the code. So let's see how it does. So if you see this code, this is a very simple function addition, which can take two values, and it returns the summation. And I'm just calling this particular function in a loop which runs or iterates around 1,000 times. So what is the output? As we can see, it's only 5. So that means how many times it iterates doesn't matter, it always returns 5. So compiler understands, okay, then can we do like this, instead of this thing, can we just say only 5, because eventually it will print 5 only, right? So that's the reason it's a super kind of optimization that the profiler and compiler it does. And finally it creates a different language which is basically a machine code that directly understood by the computer. So that's a very high level. I just wanted to give you an idea like how the JavaScript engine works behind the scene, and what are the different components that are quite essential to understand. Yes, without knowing JavaScript engine also, you can write your JavaScript code and it will work and you can complete your project. But having a good idea about the JavaScript engine, like how does compilers and interpreters work, and how can make your code much more optimized. So it's basically probably helps. That's what I thought. Call stack and memory heap. These are quite important things, of course, which I didn't talk about in our last slide. So call stack is nothing, it tracks the current execution of the function calls, and memory heap, it basically stores the variable declarations or any variable value assignment, any function definitions. So those are all the objects that basically stores in the memory heap, and it's all pointers to that particular memory location. JavaScript is single threaded, means one thing at a time. And how we can know that? Because call stack talks about the JavaScript is single threaded, because at a time one function will be executed, and once this function is calling another function, it basically pop into that call stack level. A new function will be added to the call stack, and the similar way it grows. So it basically one thing at a time. That's called a single thread. But if it happens this way in current browsers, for example, let's say Facebook or maybe Twitter or maybe Instagram, we are just checking today, and at a time, if I just some action is taking quite a good amount of time, let's say some photo is being uploaded or something is going on, then I cannot basically run the other activities. I cannot scroll the browser, or I cannot click any other buttons, because something is actually ongoing. So until and unless that particular piece of action is not over, I cannot perform any other activities on the browser, so which is really quite not acceptable. So we have something called the web API, or kind of something which a browser actually provides, not from the JavaScript engine, but it calls a JavaScript runtime. And the runtime is basically the browsers which offer certain APIs out of the box, and a few to call out. For example, fetch, which can make certain server calls to get the data as a behind the scene, or maybe some sort of set timeout as a function, which can make some delays to create certain operations, and then once it is over, the callback function will be triggered. So those kind of things are there in the set timeout things, and these are called the web API, because the web browser is offering those kind of APIs out of the box. So what happens once I'm just making a call to my database, which will take ample amount of time to complete its task, so that time I'll make a fetch call. So the moment the function I'm calling a fetch call function, then my JavaScript engine will think, say, hey, it's basically a web API, it's not the actual program that I have to run. Rather, this kind of a function which probably web API or JavaScript runtime should take care of. So then the activity is basically offers to web API level, and JavaScript runtime takes care of, and it says, like, fine, once I'm done with my data fetch, I'll just let you know. And that time there is something called event loop, which will keep on checking, like, if this web API is sending back an information, and if yes, it is sending back an information, then it will just check the call stack. If the call stack is empty, then it says, like, hey, the call stack is now empty, and looks like I have some information from the web API which is running in the JavaScript runtime. So now you can just proceed with the rest of the activities with that details that is fetched from the database. So that way, though it's a single threaded language, but still the multiple or parallel processing is possible, and that is happening through this web API. So let's quickly check where this web API, what are this web APIs, and how we can see that. So let's check the Windows and in the browser console, and you see it Windows coming automatically, and it provides certain out of the box APIs, as you can see over here. One of the API I mentioned was a fetch, another was set timeout, something will be below down here, yes, set interval and set timeout, right? So these are the browser provided. So every browser has its own web APIs available, and let's just check one of these web API. Let's say I'm just writing a code console.log, and I'm telling it's print 10. Then I'm just writing set timeout, and it need to ask some callback function. Console.log, and I'll put something called, let's say, 30, and I would like to put some delays. That's it. and then again print something called 20. Okay, so this is the piece of code. So 10, then 30, then 20. So what do you think, like it will work? Or maybe something I can say, this is 20 and this is 30, just to make a little bit of interesting. So ideally I'm just printing 10, 20 and 30, but the 20 will be printed after some interval. So if I just run, you see it first printed 10, then it printed 30, but the set timeout is actually taking this one as a background. It's waiting for some time, and then this once this is the time is over, then this callback function, which is an arrow function here, is gets called, and it says like, hey, can you just now print this 20 for me, and in the console log it prints 20. So that way the web API and JavaScript runtime and JavaScript engine uses these concepts to make JavaScript as an asynchronous language. Let's quickly understand JavaScript hoisting. So in this piece of code, as you can see, like I have a variable called name1, and I am adding a value Somnath to it, and I have declared a function called print name, and from there I'm just doing a console log hello Somnath. So what happens, like the moment JavaScript finds this kind of syntax where name1, it basically creates this variable in the global execution context. So means like if I just check window at this moment, you see there is nothing called name1. Okay, here you see some name variable, maybe some old code is there. So name1 is not yet there in the window. Okay, name1 that time was created, but name1, as you can see, is not there. Good. So now if I just write window dot name1, what will happen? It will say undefined. But again, if I write window dot print name, it is also undefined because the code is not yet executed and it doesn't know what it is. So I have put a debugger or breakpoint over here. So let's run the code and see how things going. So at the first time, my console log prints this dotted line, right? And this time my code not yet executed this particular name on a print function. But if I now see window dot, if I just enter window and go here, I'll see that particular property now got created. Let's go there little. You see the name1 is got created automatically. But as this particular line is not yet executed, so only the partially this variable is hoisted to the global execution context. So I can see the variable, but I cannot see the value yet. Okay, that's good. So let's do something like one more thing. Let's say window dot print name. If I just check this out, you see this is a F sign is there. So if I just enter, you see the enter piece of this function is hoisted to the memory. Okay, and I can see the function code completely. So means always remember the function is completely hoisted, but variables is partially hoisted. So at this time, if I just run the code, what will happen? It will print undefined because the name doesn't have any value. It is go to print function now, and it will basically console log the enter text hello Somnath, as it doesn't return anything. So we can see undefined again as a return value. But now name1 is actually set a value to Somnath. So that means now I can see the value Somnath under Windows once this line is executed. So now it's executed, and if I now go to window dot name1, and you see now the Somnath is appearing. So this is how the hoisting works in JavaScript. Let's quickly understand what is IIFE, or immediately invoked function expression. So as we have seen that we have something called a global context, global execution context, where we have our variables and function gets hoisted. So now the challenge would be like if the same function name, let's say for example some print name or whatever the function that I'm just hoisting to my global context, if the same name is also available in one of another library which I have just added to my application, so then there will be a problem of namespace collision, because that function will also be trying to hoist it to the same global execution context. So what I wanted to mean is, so let's say this is my script which is having currently no function, I believe, nothing is available. So let's create a quick function and I'm calling it as new feature. Okay, and this features talks about like return new feature is added. Okay, some features that I have added for my customer. So what will happen if I just execute this application? So let's go back, minimize it. Okay, so now I can just call this new feature in the console because it's now hoisted. And if I just call this function, I'm saying like new feature is added. So now let's assume I'm adding up a library and it will be added as a script tag over here in my HTML page. So adding up a library, and I just want to make it a little bit easier for our demonstration, I want to add the same function over here, right? Same function called same function new feature. And if I just now write something like your feature is deleted, okay, something like this. So what will happen if I just run this one? Your feature deleted. That is completely bad, right? I mean, that is not the expectation. But yeah, as I said, like the new feature is now also hoisted, and it's actually overwrites the earlier function value function, hoisting, whatever, like entire function gets hoisted. So that bit gets now overwritten with this new function because it's the same name. So now to protect this, so that the library which I'm offering to be used in any application, I need to make sure that my function should not collide with the global namespace. So before ES module concept, there was a thing you used to have in usage, and that is called IIFE, or immediately invoked function expression. So let's see what is that and how we can minimize these conflicts. So what I'll do, I'll create a variable. Let's say my variable name is script, and I'm creating a expression, not a function. So parenthesis, and there I'm just adding up this function. Okay, so now JavaScript interpreter says like, hey, this is no more a function, but it's a function expression because it's starting with a parenthesis. That means I can call immediately, and that's why it's called immediately invoked function expression. What I'll do, let's remove this name. I don't want to add any name. Let's little bit maximize this one. Yeah, I don't want to add any kind of an anonymous function, but here I want to create a new function again, and with the same name, new feature. And this function, I would like to have my own code, my own functionality, whatever I have, right? So that's pretty good. I'm adding up over here. And what next I'll do, I'll return something called this new feature, right, as an object with the same name as new feature. So now what will happen, the moment I now execute, right, the function is not getting collided. You see, is still showing new feature is added, whatever is my current application was behaving, which you can see in our script.js file. Now if I just see, so how to access this library feature then. So library is actually sending or returning some function called new feature, which comes under the top of this script variable. So now the script is actually loaded, which is my library, let's say, and script will have a function called new feature because this is I'm returning. So new feature, so it's a function I'm returning, so obviously I can call this function from here. And now whatever the library is offering the functionality, I can enable this, because now the functionality says your feature deleted. So that means it's not conflicting with my existing application behavior. So this kind of a concept is called immediately invoked function expression, and it has this kind of usage. jQuery uses a lot this kind of concepts and kind of a plug and play options. Yeah, so good to know about this part about IIFE. Let's check something like call, apply, and bind option. So to explain, let's create a function called print hello, and here I can just console log hello. So now I can invoke this function simply by this parenthesis, and if I just execute, okay, sorry, I had to add, I think, some problem with this parenthesis bracket. So if I just call it, it will basically console log hello. There is another approach, and that is something called call. And so if I just do this, it is doing the same thing. Okay, print hello dot call. It's actually similar thing. So the short form is basically this two parentheses we call to make it short. Okay, so that is the call. So now thing is, if I just go for an apply, it does the same thing. You see, same thing. So there is no difference between call and apply, but it has basically a different features altogether. And to understand the power of call and apply, let's create a simple example where I'm thinking like I have one variable called account underscore one, and this account has a name, and let's say name is Somnath, and it has something called, I should give a comma, something called balance. Okay, so this account balance, let's say $100. Now let's assume I have similar way another account, and it's account 2, and the name is, let's say, John. Okay, and its balance is, let's say, 150. Now I have a function, let's say payment, and this function actually takes two parameters. One is something, the account as an object, and the amount that I want to pay. Okay, and it simply returned the account that I'm interested dot balance is equal to account dot balance minus amount, as simple as that. Okay, so now if I just execute it, and if I just run call payment, and I can give, let's say, account underscore one, and let's say $30. So what will happen, it returns 70 because I had $100. So $100 minus $30 is basically $70. If I keep on playing this one, it becomes 40, then 10, and then now minus 20. So the account is basically having a negative value. So we need to stop this out. For that, what I would like to do, I would like to add a feature called threshold, let's say 20. So 20 is the amount which I would like to have as a minimum balance to my account, and I want to like creating a function, and it will take a parameter, let's say amount. And now what I'm going to do, I'm going to put a condition. I'm saying like, hey, this dot balance, right, that minus this amount should be, let's put another parenthesis just to be sure it is all set. So this minus, sorry, it less than 20. Then what I have to do, I'm just console log, I'm just saying balance is low. and I'm just, let's say, returning let's say false, right? Because my balance is low. Otherwise I'll return true. Okay, so this kind of a logic I have placed. Now when I just do a payment, I would like to use this feature. So I'm saying like if the account dot, I think, threshold, right? So threshold 20, this is the function. If this function is equal to true, that means my balance is not less than 20, then I'm allowing this particular operation. Okay, and otherwise I'm saying something return something like transaction is failed. Okay, that's it. So let's see what we have done. We have just put a new function called threshold 20, and it does a check that my current balance is not less than 20. If it is 20, then it is just doing a console log that balance is low and it returns false, else it returns true. So now the payment function is now having a capability to check this threshold value, and if it is equal to true, means my balance, I have a sufficient balance to pay the amount, then this operation or line will be executed. Otherwise I'll say transaction is failed. So let's rerun this program. Some problem at 7.7. Okay, quickly just correct it out. Yep, this is a mistake. Fine. So now what I'll do, I'll again call payment. So this time try with account underscore 1, because account 1 has this feature, right? Threshold 20. So if I just run this one, yeah, it's 70. I can run 40. What do you think? 40 minus 30, it will become 10 now, but I told my balance or threshold minimum balance has to be 20. So if I run, well, it's 10. Sorry, it's a mistake, because I had to pass this amount over here also, which I didn't. So now if I run once more, so yeah, 70, 30. So now the moment I'm putting 30 again, it is giving like balance is low and transaction is failed. Awesome. So now I have a check like my minimum balance is there. Now the problem is the same feature will not work for account 2, because account 2 doesn't have this function like threshold value or minimum value 20. It doesn't have this kind of capabilities. So if I just, let's run again as a fresh and just put account 2, it will give an error, of course, because it says like this particular threshold is not a function. Now what we have to do is there is a technique like called borrowing the function from another object. So this is the technique that we need to use now. So we have the threshold 20 already created, so our code should be dry. That means don't repeat yourself. So we'll be using the same function now for this account 2 also. How to do that? The simple technique is I have to say like which object does have this function. It has account 1. Okay, and I'm borrowing from this object, this particular function I'm borrowing, and I have to pass again this account for which this particular features to be applied or to be called. But for that, what you have to do, you have to do something called call. Okay, just doing a call will make this feature loaned from this account 1 for the any account that I'm just applying. So now let's again run this one. So if I just execute account 2, voila, it started taking this option, but really it is, hopefully. Let's run again. Sorry, we have to run. I think we have made a mistake now. It's 90. Yeah, so it's reducing. Let's 30, it becomes 60. Let's again 30, it's become 30. So now if I put again 30, what will happen? Of course it will become 0. So now we have to see if really it's working or not. And yes, it is saying the balance is low and transaction is failed. So this way I can borrow certain features from another object and I can apply for the other object which doesn't have this feature. It's a fantastic capabilities. So can I use apply instead of call? Yes, we can. Only thing is, instead of amount as a value, we have to pass it as an array. That means multiple values I can pass when I'm just doing an apply. So just rerun this program and again call this one. Voila, it's working as it's as same as it is doing before, and the feature is now all set. That's about call and apply. And let's understand what is bind. Now the last one is the bind. So how this bind works? Bind works similar like call and apply. So I have to just change it to bind, and it takes the amount as a value just like call. But if I just let's run this out and see what happens. If I now call this, it says the transaction is failed, means it doesn't work the way that's what I said, right? What it happens actually, it basically returns a function which can be called later on. That means if I just take this out from this if condition or if block, or rather if condition, I'm just writing a new thing called check balance, and I'm just pressing it over here. Okay, and this check balance is basically a function which is a callable. So I'm just calling this function, and let's just arrange it. Okay, I think it's just worked. That's okay. So let's run again. So what is happening? Same thing, only point is it returns a function which can be called later on. So I'm just calling over here, and I'm just comparing with this, is this true or not. See if I now this one, you see it's working the same way as it was working before. Voila. So it's all about call, apply and bind. I hope this techniques would be useful, and how to learn how to leverage certain capabilities from one object to other. It probably a best way can be explained in this video. So let's quickly check the function carrying. So let's create a simple function, and I call it as multiply. It takes two parameters, a and b, and let's say it returns a multiplied by b. So if I just call this one, let's say console dot log, and let's call multiply and pass, let's say 5, 2. So if I just execute, it will print 10, which is quite obvious. So let's use the function carrying technique, and that is nothing but multiply and then add something called bind. And we know this bind basically generates a new function. It takes this as an argument, which is nothing but the Windows object, and let's say I just want to multiply by 2. So as we know, it returns a function. So let's do it something called var multiply by 2. Okay, and now if I just use console.log and let's say multiply by 2, and if I just passed 5, what will happen? It will again print 10. Awesome, right? So I've created a new function which is capable to multiply with 2 against any input values. So if I just put 15, it will put 30. So that means I can again copy this one and create a new function. Let's say multiply by 20 or maybe 10, right? And if I just again do a console log, and if I just paste and run, what will happen? It will basically, if I just change it multiply by 10, it will make 150. Okay, I think multiply by 10, I had to change it 10, of course, which is quite obvious, and now it should work as we claimed, like it's a new function and it's capable to multiply with a defined value and against an input value, and this is called function carrying. So thanks for watching, and I'll come back with the part 2 soon with the JavaScript fundamentals. Stay tuned. Thank you.